All right, guys, so we're going to do 12 through 20 in this video. All right, question number 12. Again, it just tells you what the graph is all about, but the first thing you're going to do is read the question. That's really important because a lot of time, you know me, there's a lot of crap in these questions that you don't need, right? So let's read the question. It says, which statement about air pollution over the city is best supported by the graph? So in this case, yes, we do have to go back. And looking at the graph, it has January, all the different Januaries, and they're increasing by a year. What's something that we noticed? That it looks like towards the middle of the year, right, it spikes. But not only is it spiking consistently in the middle of the year, but as every year it is increasing the amount of air pollution. So the fact that it is consistently happening, that we can pretty much predict when it's going to have to happen, it's going to be a cyclic event. The answer cannot be that it doesn't have a pattern, because you can predict that around, what is that, like September of every year, that you're going to have a spike in air pollution. Okay, so there is a pattern, so that's out. It's decreasing at a constant rate, not so much. It's increasing at a constant rate, again, not so much, because it increases, then decreases, then increases, then decreases. So it's a cyclic event.
And if you look at the first year, it goes from the first year to the second year, it goes up. Third year, it actually goes down. And then the fourth year, it spikes up. So that one, it's not a constant rate.
Okay. So 13, the cyclic rise and fall of ocean's tides on the earth is primarily caused by the earth's rotation and what? Well, everything you got, if my kids know what always wins, gravity, right? Gravity is always going to win. All right. So when you're looking at this, right, the fact that you're talking about the tides, you're talking about the amount of gravity that's going to happen between the earth and the moon and the sun and the earth, so on and so forth. If they're all in one pattern, right, if they're all straight across, whether it's the sun, the moon, the earth, or the sun, the earth, the moon, right, we're going to have higher high tides and lower low tides. It all has to do with that gravitational attraction. Okay. 14, scientists can plan to photograph a solar eclipse. Solar eclipses, we know we can predict when they are going to happen. We can predict when Halley's Comet is coming around. We can predict most of those astronomical events because they are cyclic and predictable. Okay? Automatically, they're not random, and they're definitely not unpredictable. And here's a trick, guys. The fact that it says cyclic and unpredictable, that doesn't make sense. If things are cyclic, they're automatically also going to be predictable. Okay, 15. For those of you who don't listen, right, this is one of those things that will tell us that the earth has a curved surface, right, or that the earth is round. An observer watching a sailing ship at sea sees that the ship appears to be sinking as it moves away. You can be on the phone with them or the radio with them the entire time, and as they go off the edge from where you're looking, it's because of the fact that it is a curved surface. They didn't actually die, thank God, but they're, it's because we have a curved surface. Okay. 16, as the altitude increases with Earth's stratosphere, air temperature generally. Have I ever asked you to memorize what happens with altitude and air temperature, specifically in the stratosphere? No. So this is when you take your handy dandy reference table. Can everybody see that? Can they see it?
Mm-hmm.
Okay. So here's the stratosphere. All right. So on this reference table, you have temperature, pressure, and water vapor. In this case, it's specifically talking about temperature. So as you're increasing in altitude, what's happening to the temperature? Well, it starts at a low temperature and goes to a higher temperature. So in the stratosphere, it is only increasing. Now you have to make sure you're specifically looking at the stratosphere, not the mesosphere, not the thermosphere, and not the troposphere. Okay, this is Earth Science Reference Table, page 14. Okay, for those of you who, I know you're writing it down off to the side so that you know what's important. Okay, in question 17, again, we're going to have to use this. Why? Because what's important? It's talking about the atmospheric layer, which is what we're talking about here, and the water vapor. Okay, remember, and some of you guys are just going to know this off the top of your head because we talked about how weather happens mostly in the troposphere and a little bit in the stratosphere. Okay, so when you're doing this, right, most of the water vapor, as you can see, is in the troposphere. Okay, question 18, which sphere of the earth covers approximately 70% of the Earth's surface. Now, that is not on here, right? That's the difference between what is an atmosphere, what is the hydrosphere, what is the lithosphere, and the asthenosphere. What?
Flip the iPad up.
Oh, sorry. I was looking that way. Okay, you have to remember 70% of the Earth's surface is made up of water. Okay, and what is the one of the four spheres that covers is water? It's going to be the hydrosphere. Okay, if you can't remember that, think of hydro kind of like hydrate, right? It has to do with if you have to hydrate your body, you end up doing this with water. Okay, which element is most abundant in the Earth's lithosphere? For 19, have I ever asked you to memorize the fact which element is most abundant? No. Has Mr. G done that? Maybe, but probably not.
Nope.
Okay, so when we're looking at it, where's the lithosphere?
First page.
No, it's not on here.
Crust.
Oh, okay. Here we go. So, right, you have to remember that the crust is what the lithosphere is, right? So when you're looking at it and it says most abundant means that it's the most that is there. So whether you're looking at percent by mass or percent by volume, it does not really matter, because both of which oxygen is the majority of it. Okay, so when you're looking at this, for this case, it does not matter if you're looking at percent by mass or percent by volume, but be careful with questions like this. It can ask you specifically what is the percent by mass of oxygen in the lithosphere, and then you have to make sure you're looking at the correct column, just as a side note, guys. Okay. Question number 20 says, near which two latitudes are most of Earth's dry climates regions found? Again, this is page 14. This is everybody's favorite reference table because there's so much stuff. There's so much information in this one little reference table. We all know this. We all hate it. Okay, see, at least it's not just me. All right, so it's specifically asking you for the dry regions. Well, guys, do yourself a favor. Don't memorize these things. It's here for you. So the fact that it's saying dry regions, we're literally looking at the North Pole, 30 degrees north, 30 degrees south, and the South Pole. All right, so all you had to do was look here and then compare it to the answers. And when you compare it to the answers, it says 30 degrees north and 30 degrees south. So most of these answers, guys, were on the reference table. At least 16 through 20 were on the reference table. And you just have to know where to look, which is why we both have been telling you guys, figure out what the question's asking and then look for it. All right?